arrow rule. So here's our rules. And let's start looking at the correlation, R, between education and study hours. So we already kind of talked about that. Education and study hours. We know one path is A. And we already just talked about this is not legitimate. That doesn't count. That doesn't work. So we're left with the correlation between education and study hours is equal to A. Or A is equal to that correlation. Well, that's convenient. This path is the correlation between the two. For A is equal to the correlation between education and study hours. Maybe our luck will continue. What about the correlation between education and grades? Education and grades, well, one path is this way, is B. But we already talked about as well, this is also a legitimate path. Mom's education influences study hours, influences grades. And remember, the rule is that it's kind of how we calculate the correlation is the sum of the products of the tracings. So it would be B plus A times C is going to be equal to the correlation. So you see some ugly math in the future for us to solve these. But we see the correlation again, B plus A times C is equal to the correlation of education and grades. We can do a little solving and come up with B, subtract A minus C, subtract A times C, and we get B is equal to the correlation between education and grades minus the value, whatever value of A is and whatever value of C is, multiplied. Finally, the correlation between study hours and grades, well, we talked about that's equal to C. And we talked about this path meets the rules. From study hours to mom's education to grades is okay, because again, that's that spurious correlation that's part of the correlation between the two. So the correlation between study hours and grades is C plus A times B. So we subtract A times B from both sides, and we get C is equal to the correlation between study hours and grades minus A times B. So we have three equations and three unknowns. So if you think way back to solving, multiple equations, we can actually make this work. Let's start with what we know. Here's the three. Here we know A is equal to this, B is equal to that, C is equal to that. And we already know the value for A. That's easy. A is the correlation between education and study hours. So let's solve for the correlation. Let's solve for B. So B was the correlation between education and grades minus A times C. We'll substitute A for A times C. A was the correlation between education and grades. So the correlation, so B is the correlation between education and grades times what was A is education times study hours, the correlation between education and study hours. And what was C? C is the correlation between study hours and grades minus A, the correlation of education and study hours times B. Nasty, isn't it? Fortunately, there's software that will do this for you. But let's just kind of go through it and see how it works. So it's not just magic. I'm not just BSing you. This really does work. You can go through. So here I've just rewritten that. And then you can go through and actually solve it. And so we'll start off by, let's multiply this out. So education times the correlation of education and study hours times the correlation of study hours and grades minus the education times study hours times negative education by study hours times B. So that's plus the correlation squared of education times study hours times B or the correlation of education and study hours squared times B. Okay? Let's then get all the B's to one side of the equation. So let's subtract this from both sides, and we get B minus the correlation squared of education and study hours times B equals the correlation of grades and education minus the correlation of education and study hours times the correlation of study hours and grades. We'll factor out B, gives us B times 1 minus the correlation squared of education and study hours equals all of that again. And then we just divide 1 minus the correlation squared of education and study hours. We divide both sides by that, and we get B is equal to the correlation of education and grades minus the correlation of education and study hours times the correlation of study hours and grades minus divided by 1 minus the correlation squared of education and study hours. So it really does work. Trust me, right? What about C? Well, we can do the same thing. Here's the formula for C. And now we're just going to plug in whatever we can and solve for C. So we just come in, and A was education and study hours. B is education and grades minus A, which was education and study hours times C. And we go through and solve for C, and I'm not going to repeat all that. But you come back with a similar, though different formula for C. And now we can, in the end, we can calculate A, B, and C just from the correlations. We just plug in the values for the correlations into each of those equations. So we go back. Notice I've carried a few more decimal places just so that the math will end up working perfectly the way I want in the end. When we get to the big aha reveal in a minute. So there's the correlations between the three variables. A is the correlation between education and study hours, which was 0.37298. B is, here's all the numbers. If we calculate that out, we get a value of 0.32953 for the path for B. And C, again, we just plug in the numbers. We plug in the correlations, and we get a path of 0.07456. So we've calculated what those paths are. And we can think about those. A minute ago we talked about, with the correlations, starting to think of these as standardized betas, kind of how the variables are related to each other. We can still think of these paths as standardized betas. They're telling you kind of how much the one variable of a standard deviation increase in one leads to a change in the other based on this causal model, including, the effects of the other variables in the model. In a simple model like this, you can actually calculate these values directly from a multiple regression. You don't have to go through the steps we just did of solving all and coming up with those horrendous formulas for A, B, and C. Think about if you had 5 variables. It would be really ugly. You could do it, but it would be really ugly. And you can do this in multiple regression, and you will do this in multiple regression in a soon to see assignment. You can do it through a series of multiple regressions, where we're looking at the standardized betas for each predictor predicting subsequent outcomes. In this case, it's based on 2 multiple regressions. You could calculate these values directly from 2 multiple regressions. Kind of the first one is you just break it into pieces of each predictor, kind of each variable in that sequential model being the outcome in order for the model leading up to that. So here's our overall model. The first step would be, let's ignore grades for a minute. You can see I've shaded it out. And we're only going to look at predicting study hours. So this is kind of like the most simple regression model based on that, or the most simple piece of that model. So we're going to predict study hours based on mom's education. Now notice to do this, our outcome is going to be study hours. The outcome is not grades. We're predicting study hours based on mom's education, because that's what the model told us, right? We predicted that mom's education influences study hours. So let's do the math. Let's do a regression where we say mom's education predicts study hours and see what we find. So our outcome is study hours. The predictor is mom's education. Again, we're really interested in grades. But to understand the totality, to understand how everything's related, we need to take it piece by piece. Well, if I do a multiple regression of study hours as the outcome, mom's education as the predictor, and here's the results of that same data, and I look at the standardized beta, it's 0.37298, exactly the same value that we just calculated. So that's good, that worked. So when I'm saying, oh, you can think of that as a standardized beta. Yeah, you can think of it as a standardized beta because it is the standardized beta. So one standard deviation increase in mom's education leads to a 0.37298 standard deviation increase in study hours. The next step is now we do a completely additional multiple regression analysis. So we have to do two analyses. And now grades is going to be, you kind of just work your way through the model. Grades is the next variable in the model. So grades will now be our outcome. And we have study hours and mom's education as our predictors. And here were our regression coefficient, here were the paths we just calculated by hand based on the correlations, were these two values. So we'll run a multiple regression predicting grades based on mom's education and study hours. And if I do that, so here, grades is our outcome, mom's education, study hours are the predictors. The betas are, again, exactly what we just calculated by the correlations. So you can either do it by hand and kind of force all those values, or you can do a series of multiple regressions and just report the standardized betas at each step along the way. And again, then that's why you can think of these just like standardized betas. This is the effect of this 0.32953 is the effect of mom's education. It's that unique effect of mom's education that's unrelated to everything else in the model. It's unrelated to study hours. So part of the effect of mom's education is that direct effect that's unrelated to study hours is 0.32953. That's how much controlling for studying a one standard deviation increase in education, and you see a 0.32953 standard deviation increase in grades. This is the effect that study hours has on grades controlling for mother's education. So notice it's a lot less than the correlation was. That's why we can't use the correlation. Because mom's education came in the model first and already took it. We're right back to the first week of the semester, or maybe the second week, where Ming and I were debating who gets the C in that Venn diagram. Notice at the time I said, we're going to come back to that throughout the semester. Here we are again. That's why this is different than the correlation. Because the model said the C, the correlation, everybody gets the C. It gets double counted because everybody gets credit for that. But in our path model, no, that's why this is not equal to the correlation, because it all went to mom. Pretty cool. Now, there's additional things in our model. There's additional fact variables that are not in our model that can also be influencing both study hours and grades. You know, does the kid work? Does he date? Does she have books at home? You know, all sorts of possible variables influencing how much someone may study. That we just don't have them in our model, or what their grades are. The effect of these other variables on study hours and grades are referred to as disturbances. So this is structural equation modeling language. You won't see people in regression talking about disturbances unless they're doing this sort of path sort of interpretation. But this is, again, in SEM, structural equation modeling, it's referred to as a disturbance. And it's similar to the residuals in multiple regression. They're also, in that sense, you'll see them referred to as residuals or errors, kind of in that same language. But I think that the deeper you get into an SEM framework, the more you'll just see them referred to as disturbances. And you can think of it this way.